Okay, so this is the second part of the notes as we're continuing here. Investigate a limit using a graph, figure 11. That's actually on the next one. We'll see it. Okay, investigate a limit using a graph. So now using these graphs right here, you guys have it on your notes and it's also up here. So if we're looking right here, so we're looking at it from both sides here as a limit is coming to it here. So now this is where the function f of x is actually equal to the limit. So there's times where it's equal to limit. That means both left and right are going to the same number, and that number does exist. Then the next one over here is going to be where the function g of x is going to a limit, okay, is going to something. The function exists up here. Here's my g right here. Okay, so g of c is up here. So there's this, that's not lined up very well. Anyway, all right, there's that spot right there. That's the piece I'm looking at. So where the function is not equal to the limit of this will still be that spot right there. But the function exists up here. So it's kind of like those ones where you have like everything goes there, but then the hole's way up here. Okay, so now this one right here, h of x, does not exist at all. So this would be an example like one of the problems that we did the other day, that it's just a hole, just in that one spot. Okay? Only in that one spot does this problem not exist. So it goes on both sides. So the limit exists, but the function does not exist. It's undefined at that point. Okay, so those are the different types that you'll see here. We'll have another type here too. All right, so use a graph to investigate this right here. So, you guys know how to add these to your calculator? Okay, take a look at your calculator. All right, documents, scratch pad right here. So here's my first scratch pad. Okay, hit it again, I get my function. I'm using radian here. Make sure you actually have that. So to do that type of function, that was a piecewise function. Right here on my calculator, there is a book. You're right next to the book. So it's actually a different type of functions to enter. So I'm going to hit that, and it's going to bring up your template for this. So I want a piecewise function like this. This is a piecewise. It is 2, and the second part right here means that this has restrictions on the domain. Right here. So the problem, can someone read me the problem?
3x plus 1.
X plus 1.
Comma x.
X.
Cannot equal.
Not equal to. Now, here's my symbols right here. There's an equal sign over here. If you hit Control, equal sign. So I want not equal to. What number?
2.
2. Very good. And now I'm going to arrow down. And that's going to give me to my next one here. And that would be what? 10.
X.
Okay, so it's going to be x equals 2. So now, let's talk about what this means. What does this mean here? What does this piecewise right here mean? Come on, class. Think about what, yes, it's separate, right? It's 2 separate though, right? Because there's a domain restriction, that's why I put in my x's.
One cannot equal to the other. So it kind of like stops like right on top of it.
Okay, so x, okay, when x equals 2, my answer is 10. But that means that when x is not 2, it's everything else, right? It's everything else but 2. It is this function here. Okay, let's see. I'm going to hit enter. All right, so I have my graph here. And we're going to do a little thing with this. It's called trace. So I'm going to hit menu, trace, Graph trace. Okay, so I could actually look at the different things here. So it's at 0, 1, and then I could just keep going. So, and it goes up by 0.3 each time if you notice. Okay. Uh-oh. So it skips over 2, doesn't it? So I can't really see what's happening there. So once I have the trace turned on like I do, okay, I could arrow either way. So while I have this, you can just enter your number. So without anything else, I'm just going to enter the number 2. I'm just going to hit 2. And now it brings up x equals 2. Hit enter. And if you notice, it's off my line. It's up here, isn't it? So now my coordinate, just for that one, it's no longer on this line, it's up here. So when x is 2, my y value is 10. So that's what I get up there. Does that make sense? Okay, so that fulfilled the requirement of that piecewise, and you're learning how to use the calculator on this. All right, let's see. All right, next one here, investigate using a graph. That's what we're doing. So now this is the problem that we just got done doing. Okay, here comes up and it's way over here from there. So I could read this as the limit of f of x as x approaches 2 of f of x. Okay, it'd be, for this case, it would be 10. Let's see. All right, so now we're going to do left hand, right hand on this. Left hand, right hand. So let's go ahead and graph this one right here. So I want you guys to graph this right here on your own right now. All right, I'm about ready to hit the graph here. So I'm going to hit, and what did I syntax? Oh, missing an X. There we go. All right, so here's my graph. Now watch this. I'll show you guys a little trick. No, thank you. Okay, I'll show you a little trick. Now watch this. You could use this mouse pad here to actually control this. So I'm just going to grab this and just move it back in, just so I could see this. So without actually rearranging my graph, I could just grab it and move it as necessary. All right, so from right here, you guys all have this here, right? Okay, so let's see. Now, using your graph right here, what is the limit from the left hand going to? From the left side, what is my limit going to? It's going to 0, right? So this is going to be equal to 0. And from the right hand, from the right side, what is the right side going to? 1. All right, so now, is the left side and the right side going to the same number? So does the limit exist? The limit does not exist for this one. So this, the limit does not exist. So we would actually say, there we go. Wow, I gotta recalibrate this pen. It's killing me now. Close enough. Anyway, so let's take a look at the next one. So right here, the limit L of a function y equals f of x approaches number c if it exists only if both one side limit exists at c and both one side limits are equal. So it exists if and only if the left and right together come together at that spot. All right, one-sided limits. So it's possible to only ask for a one-sided. Okay, that's what the little plus and minus mean if it's only asking for one-sided. Okay, now, which one of these does not exist? Okay, try and plug it in to see what we get. You don't have to plug it in the calculator. Look at the problem. These are just ones and zeros, basically. Okay, so now, from the left, what's going to happen here on my graph? So am I allowed anything on the left-hand side here? Okay, let's see. The graph would come out something like this. Right? Because I have a domain restriction here. On this one right here, I have a domain restriction. So can I have negative numbers in there? No, I can't have negative numbers because that gives me what? Imaginary, right? So there's a domain restriction there. So I can't have negative numbers. Can I have 0? What's square root of 0?
No.
I don't know, try it. See what the calculator says. Square root 0.
Oh, no, you can.
You guys?
0.
Yeah, it's 0, right? Okay, so can we have 0?
Yeah.
Yes, so there is no domain restriction. So square root of 0 is 0. That's okay. Okay, so can we have this right here on the right-hand side? Okay, right-hand side we can. Left-hand side we cannot. So does the limit exist? Come on now. I know it's early. Does the limit exist? Does the left hand and right hand both go to the same number? Class, say no.
No.
Thank you. All right, let's try this again. Class.
Yes.
Okay. Does this one here and this one here go to the same number? No, they don't go to the same number. So if they don't go to the same number, I would say that the limit doesn't exist, right? Yes.
Okay, so like the left and the right have to like have the same number.
Yes.
So,
That's exactly what I'm saying.
yeah, you're just working.
Right here. So the left and right has to go to the same number. So if we go back, where are we at? Here. Okay, from this graph. I have this going this way and this going this way. The limit exists here. Okay? Going this way, going this way. It doesn't have to be equal there. Going this way, going this way. Left and right both have to go to the same number. The left side on this one did not. Okay, it didn't exist there, so I can't take a limit there. So can't take a limit at endpoints. Use the graph to investigate this. Graph this. Write me out. Tab. Up. Trig. Sine. Control. Divide. Pi. Over. X squared. Alright? Hit that graph. Uh-oh. Dang.
Yeah.
All right, what's happening in there? It's a hot mess, right? Okay, so let's see if I can zoom in closer. Does it look like it's going to a number? I'll keep zooming in. Oh, I can't. What keeps happening here? Someone explain to me what's happening. Just look at the graph. Tell me what it looks like.
It's like an infinite, like it goes up and down and down.
Very good. It's infinitely going up and down. Okay, but as I graph it and I keep zooming in closer and closer, it keeps getting more and more lines, right? Okay, this is actually called oscillating. It's oscillating. As I come to closer to 0, it's going faster and faster up and down. So this one is not going to exist because it's oscillating right there. It's not going to a point because the left hand and the right hand together are not going to the same point. right? So you're going to see a couple sine, a couple trigonometry ones that are going to do this. It's called oscillating. Okay, your graph is oscillating, so therefore the limit's not going to exist here. Okay, I can keep zooming in all day, and I'm not going to get a left hand and right hand onto this.
So oscillating is when there's like more lines.
Yes, it keeps going up and down, faster and faster and faster. So here it is right here. So if I started with this was my graph what it started out in, and as I zoomed in, just keeps oscillating more and more and more, and as I zoom in again, it's oscillating more and more and more, and it keeps getting the same thing. So these are oscillating, so this limit's not going to exist. Okay? So that leads us to our practice problems for this unit. So in your notes, you guys have, I think it's 9 of these, 8 of these. You have 8 of these problems. Okay? And so we're going to actually do these ones together in class later on. But right now I'm going to show you the homework problems that we have. Alright? So don't forget, like and subscribe.